All right, welcome to the lesson for fraction slopes 1 and fraction slopes 2. Okay, so the first thing we're going to do is start with some notes. So I want you to look at this table here. Write it down in your notes. And I want you to ask yourselves, what is the slope? What is the slope? If we look at it, we can see that the outputs, the y values, are increasing by 1 each time. We go 4, 5, 6, 7, 8, 9. But the inputs, the x's, are increasing by 2. It goes 0, 2, 4, 6, 8, 10. Now, using our previous definition of slope, we needed the x values, the inputs, to be increasing by 1. But here they're increasing by 2. So if you remember back to, we've done this several times, when we're giving a table like this and asked to find slope, we have to expand the table to find the missing x values. So I already did that for us over here. And you see, I had to expand and put in those missing values. So instead of 0, 2, 4, it goes 0, 1, 2, 3, 4. So now everything's increasing by +1 on the inputs, but on the outputs, now instead of going up by 1, they're going up by what? By 0.5. 0.5. So we go 4, 4.5, 5, 5.5, and so on. So what does that make the slope? The slope is 0.5. Okay? The slope is 0.5. So far, we've done nothing new. We've seen decimal slopes. We've seen decimal slopes graphed. But what do we know about decimal point? Well, first of all, let's figure out the equation. We know the slope is 0.5. We know the y-intercept is 0, 4, 0, 4, because the y-intercept is always where x is 0. So if x is 0 and y is 4, the y-intercept is 4. So the equation is y equals 0.5x plus 4. But we know we can write 0.5 as a fraction as well. Slope equals 0.5, or it equals 1 over 2. The y-intercept stays the same, so we can also write it as y equals 1/2 x plus 4. Y equals 1/2 x plus 4. So now you're going to look at your first handout, fraction slopes 1, and you're going to see that it has a bunch of empty tables, and those tables don't have any function equations written in on them. So the first two, the top two, I want you to fill in this, y equals 0.5x plus 4, and then fill in the table. You can just use my values, or you can find the values yourself. And then fill in y equals 1/2 x plus 4. Okay? And notice that we didn't use the same values. We didn't use the same values here. Because here the slope is 0.5, so the y is increasing by 0.5, 4, 4.55, 5.56. But over here, the slope is 1.5. Okay, so we have it increasing in a slightly different way. Okay, so verbally, the first one is, as the inputs increase by 1, the output increases by 0.5. Write this next to yours. And on the other one, as the input increases by 2, the output increases by 1. Okay? But we said that these two equations are exactly the same. Exactly the same. Just written in different forms. But yet we got two different verbal interpretations of what that slope means. This definition, as the inputs increase by 1, that's how we thought about slope all along. But here, now we have, as the input increases by 2, the output increases by 1. So this is an example of the first time ever we've seen a slope where the input is not increasing by 1, but it is increasing here by 2, okay? And that has to do with the fact that it's written as a fraction, okay? So as a fraction, the numerator, the 1, the top, is the change in outputs. The bottom, the 2, is the change in inputs. So that's how we know as the inputs are increasing by 2, because we have a 2 in the denominator. Okay, we're going to get a lot more practice with this. So you have 3 more pairs of tables like this on the table, on your page, okay? So the first 2, I want you to write y equals 0.25x plus 3 and y equals 1/4 x plus 3, okay? And I want you to use the inputs and outputs I have. The inputs and outputs I have. Just write these into your table, okay? So over here, the inputs are increasing by 1, like we've been seeing. 0, 1, 2, 3, 4. And so the outputs are increasing by 0.25 because that's what the slope is. The slope is 0.25. So we go 3, 3.25, 3.5. And verbally, we would say as the inputs increase by 1, the outputs increase by 0.25. Now, looking at it in a fraction slope form, we know that 0.25 is also 1 divided by 4. So we can say the equation's also y equals 1/4 x plus 3. Now, I want you to use these inputs, 0, 4, 8, 12, 6, 16, because the 4 is in the denominator, so our inputs are increasing by 4. 0, 4, 8, 12, 16. But we have a 1 up here, so what's our input, or what's our output increasing by? It's increasing by 1, just 3, 4, 5, 6, 7. Okay? So verbally, we would describe this one as inputs increase by 4, 0, 4, 8, 12, 6, outputs increase by 1, 3, 4, 5, 6, 7. Okay? So again, this is another example of how when the inputs are not increasing by 1, but we still have a slope. The slope is 1/4. All right, we're going to look at 2 more examples of this. Looking at another decimal we know, 0.75. Okay, so fill in this table, same thing as before. The inputs are increasing by 1 and the outputs are increasing by the slope of 0.75. So we would describe it as the inputs increase by 1, the outputs increase by 0.75. But we can also write 0.75 as 3 over 4. So we can also write it as y equals 3/4 x plus 10. So our input is 4, increasing by 4. So we go 0, 4, 8, 12, 16, just like in this one. But now our numerator here is 3. So our inputs are our outputs are increasing by 3. We go 10, 13, 16, 19, 22. Okay? So we would describe this as the inputs increase by 4, the outputs increase by 3. All right, so what have we learned so far? We can now interpret slopes with where the input isn't increasing by 1, okay? But just because we can do this now doesn't mean we haven't been doing it all along. So the last example is looking at a slope that is neither a decimal nor a fraction. Just y equals 5x plus 4. Very simple. As the inputs increase by 1, the outputs increase by 5. So 0, 1, 2, 3, 4 for the inputs, and then the outputs are 4, 9, 14, 19, and 24. Okay? They're just increasing by 5. But we can also write it as y equals 5 over 1x plus 4. And notice we get the same table of values, the same table, even though here we have a fraction and here no fraction. But they both can be described using the same language. So We've actually been doing fraction slopes the entire time, except the input was always increasing by 1. What does it mean that the input was increasing by 1? Well, it means the denominator is 1. 5 divided by 1 is 5, so we've just been writing it as 5 instead of keeping it in its fraction form. But not all fractions are like that, obviously. We have 3/4, we have 1/4, we can do 1 over 5, 1 over 7. So now it's time for us to expand our understanding of slope to include these more complex fractions. All right, so this is the end of fraction slopes 1. You should have that first handout completely filled in by now. If not, fill it in using these tables that we've been talking about in this lesson. Now we're going to move on to fraction slopes 2. It's not really much of a lesson. We're just going to go over the first problem together so y'all know how to do it. So you're given a table that's blank with a function equation with a slope that's a fraction, okay? So this fraction slope is 2 over 5. The 2 is the change in outputs. The 5 is the change in inputs. So the numerator is always change of outputs. Denominator is always change in inputs. So we can write this as the inputs increase by 5, the outputs increase by 2. So this helps us fill in the table because we can just add 5 to the inputs and 2 to the outputs. The only problem is we don't have a starting point. So the starting point we're going to use is the y-intercept, okay? So instead of plugging in a bunch of x values to get outputs, we can fill in the table using the slope and the y-intercept. The first value in the table should be the y-intercept. We find it in the function equation. So, as we've talked about, in a linear equation, the term that doesn't have a variable is the y-intercept. So in this one, the plus 1 is the y-intercept, so the y-intercept is 0, 1. Now, if you feel uncomfortable finding the y-intercept in the function equation, you can just substitute 0 in for x, because the y-intercept is wherever x is 0, and we get y equals 2/5 times 0 plus 1. 2/5 times 0 is 0, 0 plus 1 is 1, so the y-intercept is 1. Once the y-intercept is found, we can fill in the table using the fraction slopes. Okay, so we fill in the y-intercept, 0, 1, and now we know the inputs are increasing by 5. So 0 plus 5 is 5, 5 plus 5 is 10, 10 plus 5 is 15. Okay, and now the outputs are increasing by 2. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. Okay, and we just quickly filled in the table. The whole point of fraction slopes 2 is for you to see that if you can still fill in the table by just plugging and chugging numbers into the equation, but that's going to take much longer. It's much faster to fill in tables now using the different parts of our slope, the different changes in outputs and the changes in inputs. The only work required is for you to find the y-intercept, because the y-intercept is going to be the first solution in the table, and it's going to be the solution that helps you find all of the other solutions in the table. Cool. All right, so finish this handout, yeah, the work for the previous 3 lessons will be posted on Blackboard later.